Yeah, I want to do a few examples from your work on Friday. Just be sure you understand how to put numbers into scientific notation, okay? So here's just a few problems. I'll do maybe 2 or 3 from each section. Number one, you had 80, what is this, 80 billion tons. Take the doorstop out. Take the doorstop out. Take your AirPod out. Alex, how would you turn 80 billion tons into scientific notation?
8 times 10 to 10 tons.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And make it 8.0. You said 10 to the what? 10? 10 to the 10. Now, you guys have to write the unit of measurement at the back. If you didn't do that, lesson learned. You're going to hear me say this a lot throughout the year. 99% of the time in this class, there's a unit of measurement. You've likely never had this before in your life, so it's going to take some getting used to. You have to say what it is. You can't have a naked number. Alex, if I ask you how old you are, what are you going to say? Okay, 15 what? Years. Good. If he just said 15, I don't know what the heck he's talking about. 15 days, 15 seconds, 15 centuries. I don't know. But fortunately, he said years. That's good. Let's see. James, how much do you weigh? So 155 what? 155 tons? I don't know. Pounds. You got to make sure you specify what unit of measurement is that you're talking about. Let's do another one of these from your homework. 4, 6, 5, 0, 0, 0, 0, 0, 0, 0 years. That looks to be 4,650,000,000 years. Drew, can you put that into scientific notation for me? Now, you said 4.6 for a second. What will that 5 make that 6 do? Round it up. Now, you have 2 choices here, and I'm going to get into something tomorrow that will affect this. But for now, it would be 4.65. I will be getting to something tomorrow, guys, where you will have to do some rounding, but you're not there yet. So just go with 4.65 times 10 to the what, Drew? To the 9th? I saw you counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, 4.65 times 10 to the 9th, what? What's the unit of measurement? Years. Okay. That's how you would convert these large numbers into scientific notation. Remember that you're turning a larger number into something more manageable. You shift the decimal to the left. And the exponent represents the number of spaces you moved it. And if you're going to the left, it's positive. Let's do a few that were on the backside. We got 0.00059 grams. Madeline, can you tell me what this would be in scientific notation?
5.9 times 10 to the 4th.
1, 2, 3, 4. If it was 5.9 times 10 to the 4th, hold on. You said 4. Look at how many spaces I moved the decimal. 1, 2, 3, 4. Your answer would be 0.59. You have to move the decimal to make the number between 1 and 10.
5.9 times 10 to the negative 5th.
Better. 5.9 times 10 to the negative 5th, what? Madeline? Grams. So she chose 5 because she moved the decimal 5 times. How do you know to move it 5 times? Your final answer must be a number between 1 and 10. She initially said 0.59. That's not between 1 and 10. So she fixed it and got 5.9. The reason why the number is negative is because she's shifting the number to the right. Let's do one more. Actually, two more. Okay, Kaylin, can you do that one for me?
2.356 times 10 to the negative.
Negative what? Negative what? No, you gotta have an exponent. Negative 4. Let's double check that. 1, 2, 3, 4. That checks out. And then why did you choose negative? You're going to the right. And then you also said grams. Good job. Okay. And I do want to show you guys number 23 that was on your work because you might see this every now and then. And the worksheet actually says trick question. I wish it didn't. You got 1.000000000 milliliters. Do you need to move the decimal? You don't need to. So do you know what the exponent is when the decimal is where it already should be? 0. The answer is going to be 1.0 times 10 to the 0 milliliters. You will see that every now and then, and it's almost as if your brain locks up. If the decimal is already where you want it to be, it's 10 to the 0. Okay? Okay. Where we left off was I was trying to teach you guys how to add and subtract using scientific notation. So I want to get back to that. Yes. So this is where we left off at the end of class on Thursday when I was here. When you are adding and subtracting, the exponents must be the same. What's that? Okay, the exponents must be the same. And so everybody understands what I'm talking about when I use words like exponents, coefficients, blah, 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 blah. You may want to write this down. This number here is called a coefficient. That's your whole number. This is your exponent. Then here's your unit of measurement. Grams, meters, kilometers, seconds, years, whatever. Whenever you are adding or subtracting, you have to make sure the exponents are the same. So I'll give you guys an easy one. Jade, are the exponents the same? Yes or no? So do you need to do any adjustments? No, you do not. All you have to do is add. So 4 plus 1 is 5. 7 plus 4 is 11. You got 11.5 times 10 to the 4th. And I think I know what you're going to say. But I want you guys to look at that final answer. Take a look at the coefficient. Is that number between 1 and 10? This is where a lot of you are going to lose points, and you can't say I didn't tell you. You have to look at what you think might be your final answer. That coefficient right there, the 11.5. That is not between 1 and 10. So I need your help to get it into the appropriate scientific notation, which is to put that 11.5 into a number that's less than 10, but more than 1. So we need to shift the decimal around. Which way should I shift the decimal, and how many places should it be shifted? Left to the 1 time. So you're no longer going to have 11.5 times 10 to the 4th. It's a really ugly arrow. Let's try it again. You're going to have 1.15 times 10 to the blank. And let's see if you can remember. When you're going to the left, are you going up? You're getting more positive, or are you going down? You get negative. So is it going to be 10 to the 5th or 10 to the 3rd? It will be 10 to the 5th. This is where some of you will lose points. I'm sorry to say, I hope I'm wrong. I welcome all of you to prove me wrong. But there are some of you that will make a mistake, and you have to learn from your mistake, hopefully. I say all the time, making mistakes in this class is part of the process. You gotta understand that you can't succeed until you failed. You can't do it right until you've done it wrong. So if you make that mistake, you're gonna have that, oh God, oops. We've all been there. So just accept that, learn from that, and move on. I'll give you another example. And I think this is where some of you, Madeline, I remember on Thursday, Kellen said, "Do you get this?" And she's like, oh. I feel you. I felt like I was back in high school myself. I know that feeling. So I want to help you guys out on this. Okay. 8.8 times 10 to the 6 minus 2.2 times 10 to the 4. Let me go get my calculator real quick. Oh, here we go. I'll just use my phone. All right. Now, Ben, where you at? All right, Ben, are the exponents the same number? No, they're not. So I'm going to tell you what, you have a choice. And either choice you take, eventually you will have the right answer. Ben, we need to get these to be the same coefficient. So here's what I'm offering you. We can either do what we need to do to make that 10 to the 4th, or we can do whatever we need to do to make that 10 to the 6th. What do you want to do? It's your choice. You want to make 10 to the 4th, 10 to the 6th. Okay, so he wants to turn this one into 10 to the 6th. So Ben, does that mean that we need to shift the decimal 2 to the left or 2 to the right to go from 4 to 6? Okay, so what would 2.2 be if you shifted the decimal 2 places to the left? 0.022. I like it. So we got 8.8 times 10 to the 6th minus 0.02 times 10 to the 6th. You are correct. Now, Ben, are the exponents the same? You sure are. So now you guys are free to do your calculation. So 8.8 minus 0.02. And you are welcome to have your calculators out. You cannot use your phone on the test, so make sure you have a calculator with you every day. This is 8.78. I mean, listen, to let you guys in on a little secret. When I took the test to be certified to teach this class for the state in the state of Florida, they gave me three things. They gave me a conversion chart, so I know how to turn like a foot into a meter, imperial to metric. They gave me a periodic table, and they gave me a 4-function calculator. If they gave me a calculator to take my test, I will certainly let you use a calculator on your tests, but you can't use your phone. I could go to my desk right now, but I don't want to get up. So I'm just going to use my phone, but you guys need to have a calculator with you every day. All right. Are there any questions? Now, Ben, before I move on, last thing, let's just double check something. Is this coefficient currently a number between 1 and 10? So do you need to do any further manipulation? You're fine. It's fine the way it is. Yes, sir.
You always round it?
Today tomorrow I'll tell you what to round, okay? For now, just go with what we got here. So isn't 8.8 minus 0.02 8.78?
Yeah.
Okay. Are you asking why did I not make it 8.8?
I'm like, why just make it 0.022?
Where's the good point. 0.022. Let's do that. So I see what you're saying. That's on me. So 8.8 minus 0.022. So 0.778. I see what you're saying. Tomorrow I'll teach you about the rounding. Now, I think we're ready for the next step, guys. If there are no other questions with addition and subtraction. All right. Let's do multiplication and division. This one's actually easier. Multiplication and division. You don't have to do any readjusting before you actually do the math. You're going to multiply or divide the coefficients. When you are multiplying, you add the exponents. When you are dividing, you subtract the exponents. Let's do a couple examples. What do you do with the 2.3 and the 1.4? Look at my instructions. You multiply them. Now, the biggest thing that a lot of you will be guilty on is let someone else do the math for you. If you can't do the math now, the test is going to look really foreign. So every time we do a practice problem in class, use that opportunity to do it on your own. So, Chris, can you tell me what was 2.3 times 1.4? This Christopher Carlo. 3.22. What do you do with the exponents, the 7 and the 2? You add them. So what? This is easy. What's 10 plus 2? Or 7 plus 2? That's it. Now, Chris, before we check this off our to-do list, I want you to take a look at the coefficient. Is it in the proper format now, or do we need to do any shifting? Why is it good the way it is right now? It's between 1 and 10. There's some of you who are in here, I bet, that are wondering, how do I know if it's in the right format? If the number is between 1 and 10, you're fine. You're good. And Chris said 3.22 is between 1 and 10. I don't need to do any shifting. So that is correct. I think multiplication and division is easier. Let's do a division problem, then we'll move on. All right, Jackson, you got this one. You have a calculator on you? I want you to do that once you've written it down. Everybody should take these opportunities to do them on their own. If you wait for someone else if everybody waited for someone else to do it, no one would do it. It would never get done because we're all waiting for someone else.
4.125.
Very good. Now, do you need to do any shifting, or is the number fine the way it is? Why is it fine? It's between 1 and 10. Very good. Any questions with this? How did he get 4.1? He divided 9.9 by 2.4 in his calculator. You subtract the exponents, you divide the coefficients. With multiplication, you multiply the coefficients and you add the exponents. Okay. Now, are there any lingering questions, concerns, issues you guys want me to clear up? Okay, let's get to the last part of this. And this next one is going to be a tool that you will be using for a very long time in this class. If you don't have a calculator, you need to get one out. This is dimensional analysis. Dimensional analysis is a way to convert numbers from unit to unit. And there are three things that you guys will need to identify when you are doing this. And I am 50-50 sitting here on giving you guys a reading quiz. Because when you are reading word problems in this class, you need to be able to identify three things. I'm going to help you out with this. This is always sometimes a bit of a struggle. The things that you need in order to properly perform dimensional analysis, and it sounds a lot scarier than what it is. It's just multiplication and division. This class is just basic math, but the tricky part is, how do I know when to multiply? How do I know when to subtract? How do I know when to divide? Because if you multiply when you should have divided, or if you add when you should have subtracted, your answer won't be what it should be. I have no doubt all of you know how to multiply, subtract, add, and divide. But how do I know when to do it? That's going to be the tricky part. In order to properly perform dimensional analysis, you'll need three things. One, the known variable. I'm just going to call that your known. Two, the unknown variable. I'm going to call that the unknown for the whole year. Your known, your unknown, and then you're going to need conversion factors, whether it be one or multiple. So I'm going to give you guys an easy one. I'm going to write out this word problem. You do not need to write out this word problem. Give yourself about a 10-second, 20-second break. But I want you to help me identify the known, the unknown, and the conversion factor, okay? A football field is 120 yards if you include the two end zones. How many feet long is a football field? So this is a layup. This one's pretty easy. I'm going to start you off easy. We're going to work our way up to the tougher ones. I don't tell somebody to run a 5K before they can even walk. A football field is 120 yards. If you include the two end zones, how many feet long is a football field? So the first thing I would have to have is my known value. Can you tell me what the known value is, Jose? Read the word problem. This is where the reading comes in. Correct. 120 yards. Joseph, can you tell me what the unknown value is?
How many feet long?
X feet. Good. And now this is something that you guys may know at the top of your head. If you don't, this is why I had the conversion chart with me. Do you know how many feet are in a yard? How many? 3 feet. There's your conversion factor. 1 yard equals 3 feet. And you can flip that. 3 feet is equal to 1 yard. 365 days equals 1 year. 1 year equals 365 days. You can flip it either direction. So I'm going to show you guys how to set this up so you can actually do this dimensional analysis. Here we go. You start with your known value. 120 yards. You then set up a division table in parentheses. You should really be doing this. On the bottom of this conversion table, you will put you'll put your conversion factor, but you want to make sure that you put whatever unit you got from your conversion factor in the same unit of measurement. I know there's a lot of gobbledygook. What is my unit of measurement right here on my known value? Yards. So in this table, in this conversion table, I want to put yards on the bottom. Now, this is my conversion table. In my conversion, how many yards do I have? How many yards equals 3 feet? 1 yard. And then on top, you'll put 3 feet. This basically means 3 feet equals 1 yard. 1 yard equals 3 feet. Guys, I'm telling you, there are 16 units in this class. You are in unit 1. This math was something that you'll be using till May. So I want you to get started off right. This is how you set it up. Now comes the math. If you stopped right now, yards cancels out. So what would your answer be measured in? What's left? Feet. If you stopped right now, your answer would be measured in feet. Ask yourself, do we want our answer measured in feet? Yes. Then we are done setting it up. So now you may do your math. So I know you all know how to multiply and divide, but you got to know what to multiply, what to divide. 120 times 3. Put that in your calculator. 120 times 3. So you might be able to do it in your head. And then you would divide by 1. So what is 120 times 3? 360 divided by 1 is, your answer is 360. And what's my unit of measurement? Feet. This is dimensional analysis. On a scale of 1 to 10 or 1 to 5, 5 being the hardest, 1 being the easiest, this was a 1. So that means that there is room for challenge. So let's do this. What time we get out of here today? 11:30. We got 9 minutes. I'm going to give you a good one. Okay. Let's pretend that I turned 38 today. I'm 37. Let's say I turned 38. You don't need to write this word problem down. I want you to focus your energy on the math. Mr. Thorson turned 38 years old today. How many seconds old is he? On a scale of 1 to 5, this is probably a 3 or a 4. I'd say a 4. Okay, So what is my unknown, Jose? X seconds. What's my known, Joseph? 38 years old. I need multiple conversion factors here. Can you tell me some that I would need? From what to what? Go ahead. Seconds to minutes. What's the conversion there? Okay. 1 minute equals 60 seconds. 60 seconds equals 1 minute. Is that the only conversion factor I would need? What else do I need, guys? Minutes to hours. What's the conversion there? 60 minutes equals 1 hour. 1 hour equals 60 minutes. Keep going. What else? 1 day equals 24 hours. 1 hour, or excuse me, 24 hours equals 60 minutes, or 1 day. There we go. Am I good? I think we need one more. What's the last one we need? 365 days equals 1 year. 1 year equals 365 days. So you're gonna have 4 different conversion tables to do. I'm going to show you how to set it up, and you just got to do it methodically. Do it one at a time. There's an old adage: you cannot eat an elephant in one bite. You got to do it piece by piece. So I'm going to show you guys. I'm going to help you set this up. Now, in this class, you're not going to be doing years and things like that. You're going to be doing moles and grams and liters and atoms and stuff like that. That's why we're doing this. So I have you for what did I say? What time are we at here? 11:30. I got you 6 minutes. We can do this in 6 minutes. You start, what do you start with? Your known or your unknown? Look at what we did with the football field. We start with the known value. What was my known value? 38 years. I'm glad you said years. You didn't just say 38. Good job. He said 38 years. Okay, look at all your conversion. You got 4 different conversions. Which one should we use? Years to days. What is the conversion for that, Alex? 365 days is equal to 1 year. Now, the fact that my known value is in years, what should I put on the bottom of the conversion table? Should I put 365 days or should I put 1 year? You want the years to cancel out. So 1 year goes on the bottom. 365 days goes on top. Years cancels out. If you stop doing your math in your setup right now, what would your answer be measured in? Days. Do we want days according to our unknown value? What should it be measured in? Seconds. So we got to keep going. Draw another conversion table. What should we convert days into next? Hours. Where's Debbie? Debbie, what conversion should I use to turn days into hours? Where should I write the days? On the top or on the bottom? Good. 1 day is equal to 24 hours. If we stop now, your answer would be measured in hours. I don't want hours. I want seconds. Okay, Sawyer. What conversion should I use? Come on, get out of here. Hold on. There we go. Okay, Sawyer, what should I use to for my next conversion? Where should I put the hours, top or bottom? Okay, 1 hour is equal to 60 minutes. And by the way, days cancels out, hours cancels out. We need one more conversion. Drew, what should I put for my last conversion? 60 seconds over 1 minute. Okay, guys, this is the reason I said this isn't a 5 is because look what the denominator is for everything. It's 1. So you really don't have that much. You don't even have to bother with division. You're going to do 38. Here's what you technically would do. If you want to get technical, here's what you would do. 38 times 365 divided by 1 times 24 divided by 1 times 60 divided by 1 times 60 divided by 1. Here's the path that you go. Multiply, divide. Whoop. Multiply, divide. Multiply, divide. Multiply, divide. But because, that's being technical, but because all the bottom numbers are 1, do you really need to bother with division? Not on a problem like this. So this is straight up multiplication. What is 38 times 365 times 24 times 60 times 60? 38 times 365 times 24 times 60 times 60. Somebody tell me that number. It's a big one. Go ahead. That is 1,198,368,000 seconds. That's how old I will be the second I turn 38. I need to put that in scientific notation. That's way too big. What would it be in scientific notation, Varun? What's my unit of measurement? Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, right. 1.1. My eraser is a little slow here. There we go. And that's to the 10th or 9th? 9. 1.198368 times 10 to the 9th seconds. All right. That's a good place to stop, guys.